Hello everyone. As promised, I am going to go through the answer key for the Module 6 Week 2 quiz. One thing I do want to say as we get started on this, some of these questions might not have exactly the same numbers as you saw on your quiz. So just be aware of that. There might be a slight difference, so the numerical number could be different, but the process should be exactly the same. So for question 1, we're asking how many grams of NH3, so that's going to be important, grams of NH3 are produced when 3.72 moles of hydrogen react. So looking at the balanced equation, there are two things we care about. We care about NH3, so I'm going to underline that, and we care about hydrogen, so I'm going to underline that. So those two things will matter from the balanced equation. I'm going to go ahead and write that equality as being important. So 3 moles of H2 equals 2 moles in H3. That equality will be important for solving this problem. And let's look for any other things that will be important. So for the hydrogen, we're starting with units of moles. For the ammonia, we're starting with units of grams. Or I should say we're looking for units of grams. So we might need to know the molar mass of the NH3. So that is 1 mole of NH3 is equal to 17.04 grams. Now I was able to do that calculation in my head. For some of you, you might need to think about that, but basically you'll be looking at a periodic table for the molar mass of nitrogen, 3 molar masses of hydrogen, so that's 14.01 plus 3 times 1.01. That's how I got that number. If you are different in the last digit, that's not really going to matter too much. Okay, so let's see if this is enough information to answer the question. So we have 3.72 moles of hydrogen. We're looking for grams of NH3. Let's start with the number we're given in the question. So 3.72 moles of H2. When we're starting with moles, and actually just in general, if you're not sure what to do, convert to moles. So we could think about, okay, do we need to find a molar mass here? We don't need the molar mass of hydrogen because we are converting in the other direction. We're looking for something else. So we'll go ahead then and use this first conversion factor. So we have 2 moles of NH3 on the top, 3 moles of H2 on the bottom. And then we want to use our second conversion. And so again, how we did this, the moles of H2 will cancel here. We want to do the same thing here, so the moles of NH3 cancel. So we put 1 mole of NH3 on the bottom, 17.04 grams on the top. And then let's look at the units. The moles of H2 cancel. The moles of NH3 cancel. So what we're going to do, we're going to take, multiply across the top. So 3.72 times 2 times 17.04, and then divide across the bottom. So divided by 3. Let me go ahead and open my calculator on here, and we'll look at that. Doing that calculation together. So we said 3.72 times 2 times 17.04. So we multiplied everything on top, and then we divide by the bottom, so divide by 3, and so that is our answer. So I'm going to write that here. So that's 42.26 grams. and then it says enter your answer as a number without any units. Let me go ahead and minimize that calculator for now. So I wrote the answer here. So number without any units would be 42 point, I'm going to go ahead and call it 42.26. Based on significant figures, we would probably go with 3. I'm not going to care about that. For Canvas, just a reminder, if you put 42.26 grams, Canvas will not be able to grade that. So when I go back through and check on those, you'll get the credit for that, but you're not going to get the credit for that immediately. So it will be a while when I go through that. If you had, if you did write grams in there, but you did have the right answer, you might get those points back, but you won't get the immediate feedback from Canvas if you do include units. Okay, second question. What is the limiting reagent for the following reaction when 3 moles of N2 react with 5 moles of H2? Okay, so we're given the amounts of 2 reactants, so N2 and H2, and we're looking for the limiting reagent. Okay, so anytime we're looking at limiting reagent, we need to look at basically doing the stoichiometry twice and picking the smaller amount. So we're starting with 3 moles of N2, and what we want to do, we want to convert them to the same thing so we can compare. So probably easiest to just convert to the product. So we have 2 moles of NH3. And then 1 mole of N2. Okay, if you're not sure where these numbers are coming from, they're from the balanced equation, right? There's a 2 here, there's a 1 in front of the N2, we don't write it, but there's a 1 there. So that's, math is really quick there, so 6 moles of NH3 for that one. And then for the next one, we have 5 moles of H2. We're going to do the same thing, convert to the product. So 2 moles NH3 on the top, 3 moles of H2 on the bottom. So we do the math there, kind of running out of space. 5 times 2 is 10, divided by 3 is about 3.3 moles of NH3. Okay, so first thing, we want to make sure we're comparing the same thing. So moles of NH3 here, moles of NH3 here. This one is smaller, okay? So if the question was, how many moles of NH3 do you make? We would say 3.3. The question is, what is the limiting reagent? So what we do is we look at, well, how did we decide that this is the smaller amount? We decided that based on the moles of H2. So we're comparing moles of H2 to moles of N2. We're going to run out of the H2 before we run out of the N2. So the H2 is then going to be our limiting reagent. One additional hint on this kind of a question, anytime you're asked about the limiting reagent, the right answer is never going to be a product. It always has to be one of the reactants. So we can narrow it down to those 2. And then we do this sort of calculation to figure out which of those 2 it actually is. Okay, so question 3. Let's look at question 3. Okay, question 3 says, select any substances which will be important for solving the question listed below. Indicate whether you will need the stoichiometric coefficients or the molar mass for each one. So the question here is, how many grams of vanadium 5 oxide will react with 0.455 moles of hydrogen? Instead of doing the entire question here, we're just saying, well, what's important in order to answer this? And so if we look at this, we say, okay, vanadium 5 oxide, which one is that? This is sort of a nomenclature question. So we have 2 things with vanadium. vanadium is the V. You can look that up on the periodic table if you need to. So we have this one or this one. So which one is vanadium 5? It's going to be this one, because we need a +5 charge on the vanadium to balance the -2 on the oxygen. So this is vanadium 5 oxide. Will react with 0.5 moles of hydrogen. So hydrogen is right here. So we're given moles of hydrogen. We're looking for grams of vanadium 5 oxide. Okay, so what we're basically doing here is we're figuring out how to set up the problem without actually solving the problem itself. So for the stoichiometric, we have two things. We have a stoichiometric coefficient or stoichiometric coefficient and molar mass. So we need to decide which of these we need for the various possible things in the reaction. We don't need anything for the two products, right? So the question is not asking or telling us anything about either of those. It's asking or telling us things about the two reactants. So we're starting with moles of hydrogen. So our process here is going to be converting from moles of hydrogen to moles of the vanadium 5 oxide. So this is very similar to the first question in that we're starting with moles instead of starting with grams. And then from there we'll find grams of the vanadium 5 oxide. Okay, so to do this conversion, we need the stoichiometric coefficient of H2. So we need 2 moles of H2 is equal to 1 mole of V2O5. Okay, so we'll need something like that. For the second one, we'll need the molar mass of V2O5. So 1 mole of V2O5 is equal to, you don't even need to know, but whatever that would be, grams, so you'd figure that out from the periodic table. So for a stoichiometric coefficient, we need that for both H2 and V2O5, but we also need the molar mass for the V2O5. So this one, it will be V2O5, you need both of those. This one, H2, is the only one that needs the coefficient. Just the coefficient, I should say. So you need just the coefficient for H2, you need both coefficient and molar mass for V2O5. I believe this question was very similar to one of the worksheet questions. I will say that on the exam, more than likely the question would actually be about solving this problem as opposed to simply selecting like we did here. So maybe more like that first question. Okay, so moving on to question 4. So the question is, what is the percent yield when 6.453 moles of N2 reacts and 25.35 grams of NH3 forms? Okay, so this is a percent yield question. So first of all, I think I'll put this down here. We want to define percent yield. So this is actual divided by theoretical, and then times 100%. Now, a few things about this. In order to find percent yield, we have to have actual and theoretical be of the same unit. They have to be the same units. Otherwise, it doesn't mean anything. So we can't just take these two numbers together. We have to get them to be the same. And they need to be about the product. So the product is the NH3. So that's telling us, so this is saying this is what forms. This is the actual yield. Okay, so that will go down into this equation just as it is. We don't have to do anything to change that. This one, though, is not. This one is not the theoretical yield. We have to find theoretical yield from this number. So how we do that, we'll start with this number, so 6.453 moles of N2. And we will convert from that to get units of grams of NH3. Maybe before we do that, maybe I should make a list of conversion factors we might need. So we have moles of N2 and we have moles of NH3. We'll need those two things. I'm going to actually go and cross this out. We don't care about the hydrogen for this question. So we can say 1 mole of N2 equals 2 moles NH3. Okay, so that's from the balanced equation. We can also find the molar mass of NH3. We've looked at this in another question on this quiz. The quiz had the same reaction coming up again and again, right? So you can use that again. And this is for 1 mole of NH3. Okay, so those are the things we need to find the theoretical yield. So we have the moles of N2, and we have 2 moles of NH3 divided by 1 mole of N2. That will cancel out our moles of N2, and we have 17.04 grams over 1 mole of NH3. And so moles of N2 cancel, moles of NH3 cancel. Let me go ahead and go back to the calculator. And so I'm going to be typing in the numbers we're showing here. So 6.453 times 2 times 17.04. And so we multiplied across the top, and then we'll divide across the bottom, which is just a 1. When we do that, we get 219.9 grams. Okay, so then we would, let me again move this calculator out of the way for the moment. Then our actual divided by theoretical would then be, our actual is 25.35 grams divided by 219.9 grams times 100%. Okay, important here, so this is grams of NH3, right? This is grams of NH3. They have to be grams of the same thing in order to do this. So let's go ahead and do the math there. So 25.38 divided by 219.9, and you'll get this number, and then times 100 gives us our percentage. And this is a percent. It says, again, answer as a number without any units. So that's going to be 11.54%. Just write it as 11.54. If you put a percent in there as I go through, I can give you back some credit for that. The units here are not grams though. Okay, it's a percentage because the grams will cancel out here. One other thing here to note, you may have had different numbers in this question than the numbers you're seeing here. So if that's the case, you could go through the same process. You could go back, check your quiz, see what the number was, go through the same process, but with the numbers you had, and see what you come up with. And then finally, question number 5. How much energy is produced when 12.37 grams of oxygen reacts? Okay, so we look at the balanced equation. The oxygen is here, so that will be important. And we're looking for how much energy. So energy is the delta H, so that will also be important. So maybe we can write some conversion factors that will matter. So we're starting with grams of oxygen, so we might need to know the molar mass of oxygen. So 1 mole of oxygen is equal to 32.00 grams. Okay, so we get that from the periodic table. And then we look at energy. So in the stoichiometry, we're looking at the relationship between this substance and the energy. So we're looking at basically these two numbers. So we can say 2 moles of O2 is equal to negative 890 kilojoules. Okay, so we have our conversions. We can go ahead and do the problem. So we have 12.37 grams of O2. We have 1 mole of O2 is 32 grams. And so we've used that conversion factor. And we have negative 890 kilojoules is 2 moles of O2. Okay, so we do the math there. So let me get the calculator back. So we have 12.37. So I'm going to multiply everything across the top times 890 and then negative sign right there. So we multiplied across the top and then we divide across the bottom. So divide by 32. So that's our answer is negative 344 kilojoules. The units here, grams cancel, moles cancel. So when we write our answer, it would be negative 344. Again, don't include units there. If I go back through and check, I can check your units if they are fine, or if it's the number is fine, you can get the credit, but Canvas will not grade that with units included. So that is the answer for this question. Again, you may have had a different actual number, but use the same process. So if you go through your number, the number you had, and check that, you can see how well you did. A couple of additional things I wanted to mention going into the first exam. Again, these questions are not everything from Module 6. You would need to know how to do these. Many of these questions we had mole to mole to mass. You also need to do mass to mole to mole to mass. You could do mass to mole to mole to mole. So don't try to memorize exactly the steps. You want to understand how we do the conversions and how we select them, right? And they'll be different for each problem. So don't try to think of memorizing each of these as the way to do well. Think of do I know what a conversion factor is and how to decide what the right conversion factor is for the problem that I'm looking at. So good luck, everyone. If you have more questions about this, I have some office hours during the week you can check in, and I could even potentially answer last minute questions on Zoom that morning if you wanted to come in and take your exam in the latter chunk of that day. I will see you all soon.